Konnichiwa. I saw this article about quantum tunneling, and there's an interesting quote. Let's take a look. It says the quantum world is a pretty wild one, where the seemingly impossible happens all the time. Teensy objects separated by miles are tied to one another, and particles can even be in two places at once. But one of the most perplexing quantum superpowers is the movement of particles through seemingly impenetrable barriers. Now, a team of physicists has devised a simple way to measure the duration of this bizarre phenomenon, called quantum tunneling, and they figured out how long the tunneling takes from start to finish, from the moment a particle enters the barrier, tunnels through, and comes out the other side. They reported online July 22nd in the journal Nature. Quantum tunneling is a phenomenon where an atom or a subatomic particle can appear on the opposite side of a barrier that should be impossible for the particle to penetrate. It's as if you were walking and encountered a 10-foot wall extending as far as the eye can see. Without a ladder or Spider-Man climbing skills, the wall would make it impossible for you to continue. However, in the quantum world, it is rare but possible for an atom or electron to simply appear on the other side, as if a tunnel had been dug through the wall. Quote, "Quantum tunneling is one of the most puzzling of quantum phenomena," said co-author Ephraim Steinberg, co-director of the Quantum Information Science Program at Canadian Institute for Advanced Research. It says researchers prepared approximately 8,000 rubidium atoms, cooled them to a billionth of a degree above absolute zero. The atoms needed to be this temperature, otherwise they would have moved around randomly at high speeds rather than staying in a small clump. The scientists used a laser to create the magnetic barrier. They focused the laser so that the barrier was 1.3 micrometers thick, or the thickness of about 2,500 rubidium atoms. Using another laser, the scientists nudged the rubidium atoms toward the barrier, moving them about 0.15 inches per second. As expected, most of the rubidium atoms bounced off the barrier. However, due to quantum tunneling, about 3% of the atoms penetrated the barrier and appeared on the other side. Based on the precision of those atoms, it took them about 0.6 milliseconds to traverse the barrier. Chad Orzel, an associate professor of physics at Union College in New York, who was not part of the study, applauded the experiment. Quote, "Their experiment is ingeniously constructed to make it difficult to interpret as anything other than what they say." Okay. Thanks for watching. Arigato. Matane.